Hello, good morning, sir. I am Avinash Vankade and my roll number is 137. My domain name is image processing and having topic a scale transfer convolution network for a small ship detection in SAR image. This PPT contains outline of introduction of domain, introduction of ship detection technology, objectives, motivation, benefits of image processing in a ship detection, literature review, that is existing method, experimental works, advantage and disadvantage, applications of image processing, conclusion and future scope, and some reference through which this PPT has been made. Let's start with the introduction of domain, that is image processing. We know that in computer vision, the grouping parts of generalized image into the unit that are homogeneous with respect to one or more characteristics result in segmented image. The segmented image extends the generalized image in a crucial respect. It contains the beginnings of domain and domain dependent interpretation. Imaging is a representation and reproduction of an object's outward from, especially visual representation or formation of an image. An image is nothing but the representation, likeness, or imitation of an object or things, or a vivid or a graphic description. Sometimes it introduced the representing it sometimes introduced to represent the something else. Now the introduction of ship detection or object detection is based on deep learning and mainly divided into two subcategories, that are one-stage detection and two-stage detectors. One-stage detector includes the taking of YOLO and SDD example as they are much faster in speed, but the detection accuracy is not higher and the detection effects for small target is not ideal. It can cause error. Two-stage detectors are represented. Two-stage detector represented by RCNN series algorithm. It is slower but more accurate. RCNN is nothing but region convolution neutral network. And precision of SAR image ship target detection is higher, and the PPT mainly adopts two-stage detection algorithms. And a multilayer fused neutral network based on the context information is supposed for SAR ship detection. The paradigm of faster RCNN is proposed. The proposed method is composed of high resolution RPN and the target detection network with the context information. Rather than taking a single low resolution feature map for region of proposal, we combine the middle layer with the scale down shallow layer and the slamping deep layer to predict the boundary box. Thus the fused feature map incorporates semantic and complementary and the high resolution CNN feature. Now the objective and motivation. The multilayer fused neutral network based on the context information is proposed for SAR ship detection. The proposed method is composed of high resolution RPN and target detection network with context information. Let's see the benefits of image processing, how it would be used for us. It is used for the image sharpening and restoration. It is also used in medical field and robot vision. It is used as a pattern recognition, video processing, or there are a lot of fields where we use the image processing. This is what it looks like from satellite image. Now we talk about the literature review, or that is existing method. The literature source were searched for the Thomson Reuters, Web of Science databases, Science Direct, and the ResearchGate social media. The literature search was based on the predefined search of the following keywords, that are ship detection, ship recognition, vessel detection, and vessel recognition in publication titles, keywords, and attraction. The vessel detection is not only the topic of domain of remote sensing but quite interdisciplinary. We were able to find the articles on the subject remote sensing, geoinformatics, signal processing, applied computer vision, robot vision, pattern recognition, and artificial intelligence. And now the experimental, let's see the experimental works. The image is rescaled with the shorter side as 600 pixel. For the Archer, we used 5 scale that are 232, 264, 228, 255, 255, 2512, and 3 aspect ratio, that is 1:1, 1:2, 2:1, to cover the objects of different shape, and yielding a 15 Archer at a different sliding position. A mini batch involves 1 image, 512 Archer, and 256 ROI per image and images on GPU. We use the weight decay of 0.0001 and momentum of 0.85. Each mini batch has 2 images, and each image has 200 pix ROIs for training. Batch normalization is also fixed for faster experiments. Let's see how we decide the actual position of ship. The iteration of training are 100k. The initial learning rate is 0.001, and at every 20k it increases 10 times. To evaluate quantity of model, the metrics, the precision rate, that is P, recall rate R, and 1F score are defined as P, that is precision rate, is calculated by TP divided by TP plus FP. The recall rate is calculated by TP divided by TP plus N1. From this, F1 score is calculated like 2 into P into R divided by P plus R. From this formula, we can detect where ship is actually. These are the diagram for ship detection. Now see the advantage of ship detection using image processing. The higher speed than ever before. Switch to the software defined standard. It has a wide range of application. RCNN retrain the network, which enables to detect more boxes and achieve higher average confidence value. There are also some disadvantages of this technique that are given below. There are some security and privacy issue yet to be solved. The technology is still under process, and research is on viability is going on. It cannot be implemented real time, as it takes around 47 seconds for each image testing. Selective search is slow, and hence computation time is still high. Now we see the applications of image processing. Some applications are ship detection from remote sensing. Imaginary is crucial application for maritime security. In maritime security includes the marine traffic, marine pollution, and irregular migration, protection against illegal fishing, and vessel detection. There are applications of ship detection. Now at the end conclusion, the scale transfer for SAR ship detection. In order to detect the multi-scale ship, we can apply scale transfer multi-scale features without increasing the computation. Use of ROI align instead of ROI pooling, we get more accurate ROIs. In detection stage, we integrate the context information in the detection stage to help improve the detection accuracy. Experiments conducted in this PPT validate the superior performance, both detection accuracy and the speed. The future scope of image processing in ship detection are given below. SAR imaginary for ship detection and the recognition of the active research topic. The ship appearance in SAR imaginary are varied with the ship motion and polarization mode, observation angle, and the work condition. Most existing method includes hour and still limited by specific condition. The algorithm that are broadly suitable for user under the variety of real condition need to be developed. In in our future work, we will be continue on update the ship category database to contain more ship categories under the more complex real sea state. These are the references from which this PPT had been. This PPT is made. Thank you for your time. Thank you, sir.